at the top of our hour, so thanks everyone for joining. We'll go ahead and get started. This webinar is going to be on kind of the planning for FWA and using some of the non-traditional or non-3GPP standard planning systems out there. As usual, if you do have any questions throughout the webinar, feel free to use that Q&A panel that's in the Zoom window, and you can type in a question that will come to us, and that will be answered either through the chat, or if we can, we'll try to grab them and put them out there like we usually do here. So with that, what I'll do is I'll hand it over to Brian Jones, and Brian, he will go ahead and share his screen, and we'll kick this off.
Yeah, let me know when you can see that there, Roy.
Yeah, it looks like it's come up there.
Okay, so like Rory said, today we're going to be looking specifically at the FWA use case and kind of looking from the perspective of what if I'm a network operator or a solution provider that needs to choose the correct technology for FWA for a particular market, be it a residential market or a commercial market or what have you. And go and see if I can operate this slide deck myself while speaking. So we're sort of starting from the standpoint that there are a lot of different potentially applicable technologies, both already out there in the field, from sort of SCADA solutions and MMDS and that kind of thing that have grown and matured and now are being expanded or perhaps updated, to brand new solutions for sort of last mile delivery of broadband to homes. And there are a lot of solutions out there with different MIMO configurations and using different specifics in the coding schemes that they use. And so it can be really difficult to try and compare one against another in terms of cost and the sort of level of access delivered. And so in this example today, we're going to look at three different categories of wireless access solution. And we're mostly just going to be looking at the access layer, the sort of last mile delivery. There will be a couple of bullet points about backhaul at the end, but of course, backhaul is its own topic that we could dive into at length. So today we're just going to look at the access layers, and I've kind of divided it into three broad categories of potential solutions that you might choose for this. One of them is the 3GPP standard technologies, LTE and 5G, so 4G and 5G. And there are plenty of fixed solutions out there that rely on the 3GPP technology or standard rather, and they use those coding schemes and are, of course, in terms of the frequency bands and configurations of that spectrum, they're then, of course, bound by the 3GPP standard. Then there are the IEEE technologies, and I throw WiMAX in there because it's one of those technologies that's already deployed out there in the field in a bunch of networks, providing sort of data access for fixed solutions, including residential broadband. And so there's WiMAX, and then of course there's updates to Wi-Fi 5 and 6. I got carried away. I was going to keep writing in more numbers. Mainly today we're just going to look at a Wi-Fi, a current Wi-Fi solution. And then the third category is proprietary solutions that aren't necessarily bound by either one of these standards, but have a little bit more flexibility in terms of how they allocate spectrum and what the coding scheme is going to look like and so forth. And a couple examples of these are Motorola Canopy. I was trying to say Canopy, and I used the old name of Cambium. And then Tirana is another solution that's gaining a lot of traction. And so today we're going to look at sort of an assumed Tirana solution, and I'll talk about some of the details there. So the first thing I want to dive into, in order to give you some sort of hands-on SignalPro knowledge, is to look at how we configure the different system types. And so we'll take a look at, I've got 3 versions of a project that I'm going to show you here. And the items that we want to make sure we look at here are to make sure that our propagation and clutter options are appropriate for the frequency band that we're working with, that our link budget details, you know, transmit power, gain, channel bandwidth, all of that sort of thing, that needs to be set correctly for the solution that you're looking at. So if we're looking at 3 different solutions, we'll want to make sure and go look at the product spec sheets and make sure that if there's a different ERP limitation for one band versus another, one solution versus another, we've put that in and addressed the antenna gain and all that, you know, but basic stuff there. And then there's the system name or type in the sector details. And that's where I'll go ahead and jump to this project. Rory, let me jump in, or maybe you could jump in. Can you see my SignalPro screen? I'm not still showing the slide deck, am I?
Nope, SignalPro is up and ready to go.
Okay, great. I wanted to make sure I could swap back and forth. Okay, so in this example here, I've set this up as a Wi-Fi 5 example. So if I drill into some of my sector details here, I've got a 5.8 gigahertz. And of course, under the transmit and receive parameters are where I would set those link budget details. And then this system name or type switch controls sort of the technology overlay that we're going to put on top of that link budget and use to drive the specialized studies for getting data rate out of this. And ultimately, that's what we want to do in order to compare apples to apples between these technologies, is to look at the data rate for uplink and downlink. So by setting this system name or type switch to Wi-Fi, or LTE Pro would be what I would use for 4G, or if I was doing 5G, of course, I just select 5G. And then this WiMAX, I kind of wish it said WiMAX wireless broadband, but we were trying to be succinct. But the WiMAX is sort of a catch-all category for those proprietary technologies like Motorola Cambium or like Tirana. And the thing about the WiMAX module is that it allows you sort of complete flexibility in terms of how you set up your coding scheme and how you set up your MIMO configurations. Whereas, of course, the LTE or 5G or Wi-Fi categories, it set everything up per the standard, so that, you know, you're sort of bound to that standard if you're using those modules. So in this case, for the Wi-Fi use case, I've set it up for Wi-Fi, and this particular solution, just as a hypothetical, I've chosen a 2x2 MIMO B antenna array. And this is, of course, going to be one of the big differentiators between any broadband solution, is what sort of MIMO or adaptive antenna array it's using. And so that's going to be one of the primary differences, or these 2 items are going to be one of the primary differences that you'll set up if you're setting up sort of projects to compare different technology solutions. And what I did in this case is to take one project I'd already made and clone it by changing the system type and changing the link budget details for the already existing sites. as if to say, okay, if I wanted to modernize this project from a WiMAX deployment into an LTE or a Wi-Fi 5 or a Tirana deployment, what would that look like using the same site locations? And so to do that, I just went ahead and used save project as to make 3 different iterations of the project that I'll kind of jump between here this morning. And then I went through and made sure, you know, like I said, the link budget details are correct, system type options are correct. And under the RF systems menu, this is where we can get at that MIMO adaptive antennas feature and drill down into what does it mean to apply a 2x2 MIMO B onto the network. And more about this in just a little bit here. I want to make sure I don't get off track of my slides. Oh, yeah. So the final point there between each of these 3 projects is once I have set that system type here, so in this example, I've got it set to Wi-Fi, then I need to go and configure that technology overlay under the network design analysis menu. So in the case of Wi-Fi, I would go to Network Design Analysis, Wi-Fi Networks, and under System Details and Service Area, here's where I can choose the particular Wi-Fi system profile, and importantly, choose a Wi-Fi adaptive modulation scheme, which I just realized I was playing around with this earlier and I set it to the wrong thing and didn't change it back. So I select my adaptive modulation scheme here and a channel plan template and a system profile, and that overlays that onto each sector that I've selected that Wi-Fi system type for. And now by comparison, if I jump over to my LTE project, of course, these are all going to be set to LTE Pro. I've selected the same MIMO type. Maybe my solution would have that or maybe not. And then for LTE Pro, I would go here under the LTE Pro networks, and I can set up specific technology profiles. So in this case, I'm actually using band 66. If I was doing CBRS, I could add band 48 into here, or, you know, you can set up one or more technologies along with the subcarrier spacing and the channel bandwidth that you've got. And these, again, are all set via the standard in the case of LTE. In a Tirana or a Motorola canopy deployment, you would establish these bandwidths on the site parameters and in your channel plan template. So that's one of the differences between LTE 5G versus anything in the proprietary, you know, solutions like Tirana and Motorola Canopy. So let's go ahead and dive into each of the different examples here a little bit more deeply. And I want to point out how helpful site templates can be. So again, if I cloned this project from an existing project, maybe I've got some site locations, or I've got, you know, maybe I'm starting up with a brand new greenfield project, and I want to say, well, if I'm using Wi-Fi, then which potential tower locations would I use? If I set up a site template here, and of course you can do this under the RF systems menu, but I like to do it right with this drop down along the side of the new site tool. If I go to edit templates, I can set up a template for what my Wi-Fi access point looks like with, you know, the correct transmit power and directional antenna pattern and all of that, so that anytime I add a new site, say through the spreadsheet editor or with the automatic site placement, I can just choose which site template I want to use. So if I choose this Wi-Fi 5 access point template that I made, I could go ahead and just add a bunch of new lat longs and site names in here to get new access points configured that way. So one thing that you could do is to use that site spreadsheet and export your tower locations and then import them into 3 fresh projects using a different template in order to create, 3 different technology solutions. And, those templates really save time as well as the potential for user error. It's easy to want to just, shove everything in through the spreadsheet, or if you get used to sort of placing things and configuring them by hand on an individual site basis in here, it's easy to sort of keep doing that and not realize how much time you're losing if you get into a really big design. So I recommend using those site templates to sort of establish the differences between your different technologies. And again, we want to get into the link budget details themselves, and then under the Wi-Fi networks, system details and service area is where we would establish the system profile and the adaptive modulation table that we're using. And let me talk about this dropdown for a moment, because this is an important configuration item both for Wi-Fi or for your Tirana or Motorola Canopy or whatever solution you might be using that's sort of proprietary. Under the RF systems menu, adaptive modulation, you can set up and modify different adaptive modulation tables. So here we're showing for the 802.11ac with a 20 megahertz channel. I've set up the different modulation types, and here are the really critical numbers. The required C over I ratio, this is the carrier to interference ratio, or some folks would call it signal to noise, that's required in order to support this data rate or this throughput. And that will change depending on the technology and the configuration. And notice I've got a tab here for both uplink and downlink. And so one important step when you're evaluating one of these solutions is to make sure and check in with the equipment provider and get the coding scheme that particular equipment is going to use. And that the really important values are here. We need the C to I ratio and the data rate associated with that. And then you can go ahead and configure those in the software here. And if you have set that up and want to share it with another teammate, or, let's say you've got several installations of SignalPro, and you don't want to have to set this up for all of your installations, there are some .amod files that I'm pretty sure there's a knowledge base article about how to share those. But this is a configuration that you can share once you've set it up. And once you've set this up, it'll be available in any of your SignalPro projects. So this table here is a global item that you can set up, and you can switch between different items here. And we don't give you, a drop down with everything, because the drop down would shoot right down off the page if we included every solution provider and all the different modulation coding schemes that they use. So again, the best practice is to go ahead and reach out to the equipment vendor and find out the coding scheme that'll be used for this solution with this revision of their product, because even in the same product line, this can change. And then, of course, along with that, the MIMO and adaptive antenna configurations that you'll be using within the network. That's something that may change based on what the equipment vendor provides, or the equipment vendor, I should say. And also, we like to point out that the throughput multipliers here and some of these performance improvements are based on sort of the manufacturer's suggestion of what kind of MIMO improvement you'll get. And what we've seen is that that improvement is less in areas where there's less multipath. So if you're in a rural or a suburban deployment, you might consider backing off some of these improvements to get a little more realistic prediction of how much MIMO improvement you'll get. We do have a roadmap item for an upcoming release of the software that will actually predict the amount of MIMO improvement that you'll get, or the amount of multipath at any given CPE location or any given grid location. And then based on that, we'll scale this MIMO improvement factor. But in the current release of the software, it's important to remember that you may have to scale this number if you're in a low multipath environment. If you're in dense urban, these numbers might be pretty close to accurate, but if you're out in the cornfields, it may be less than this. I wanted to point out the channel bandwidth as well, just because it's an easy mistake to make. It's a mistake that I make all the time, and I see it in customers' projects a lot. When I'm setting up either my CPE, so the fixed subscriber device, or the mobile remote unit, if I want to do an area-wide sort of heat map or grid study, I would want to set this up in the mobile remote unit. But the equivalent receiver noise bandwidth field, that whole mouthful there, this is our channel bandwidth. And so if I'm working with a 20 megahertz channel, 20 megahertz solution, I want to go ahead and set this here and set the noise figure per the spec sheet for that equipment. And that'll make sure the receiver noise floor is accurate and that we're making the right prediction for the signal to noise ratio. And then the same thing goes on the base station. For the uplink case, if I look at the receive parameters on the base station, I've got the same value there for equivalent receiver noise bandwidth. I want to set that correctly, or else it'll be, calculating as though I have the wrong bandwidth on the uplink case. So that's my Wi-Fi project. And looking at the propagation models real quick, this is really a bit on the edge. This is a 5.8 gigahertz frequency band, and I'm using my clutter pass-through loss along with a 2D clutter data set. 5.8 gigahertz is sort of right on the fence of where I might consider switching to the add clutter height to terrain height option. And this is the more strict option that's going to treat the clutter heights as a solid obstruction to be diffracted over versus treating them as a lossy screen that gives us loss in dB per kilometer. Most of my project area here is sort of residential with some scattered trees or some treed areas that are not terribly dense. So I went ahead and selected the add clutter pass-through loss for all three of my use cases because they're 2 gigahertz and 2.4 gigahertz, and then this one is 5 gigahertz. And you'll see when we look at the comparison, I am getting slightly worse coverage, worse signal coverage in my Wi-Fi use case than my others. And that's because I'm at the 5.8 gigahertz frequency band. And I think in the LTE use case, I've also got a higher ERP, a higher irradiated power level allowed. But so, for example, on this CPE, I've got, it says 616 megabits per second deliverable. If I want to look at all the results I've calculated for that CPE, I can just go, right-click on it and go to Display Study Results. And if I want to see why it is it's showing maybe such a long link path in this case, you notice this CPE I'm looking at is linking way back here when there's other sites much closer. And if I run the path profile, of course, I can see why. It's that this site is up on a hilltop that can serve that CPE much better in a line of sight way versus, well, I think it's line of sight. Oh, we're getting a tiny little bit of grazing through the trees on one end there. But other than that, it's line of sight. Whereas these other closer sites are lower down in the valley, and so they can't reach these CPE positions. So that's, that's a good picture of my Wi-Fi performance. And if I wanted to go ahead and export the actual megabits per second for all of these CPEs, then I would go ahead and go into my study queries tool. And I can look at this either on an area study basis here, because you can see I've set up my area studies, or on a multi-point study basis. So if I want to look at just a downlink data rate from my multi-point study, and I've used consistent thresholds here. I'll click Run Query, and you can see I've broken this down to 500 megabits, 1 gig, and then 1500, and then 2000. And so you can see sort of the breakdown here of the data rates of my subscribers can achieve. And then if I want to look at any particular one, I could export this table here and get the data rate predicted to each one of these CPEs. And again, this is going to be based on the adaptive modulation table that we set up, and also the MIMO adaptive antenna. So if that looks like a really big number, or if it looks like a really small number for what you're expecting, then in here under the MIMO adaptive antenna or adaptive modulation is where we're correlating a given signal to noise ratio with a given data rate. So, and I think if that looks a little high, I think I may actually have tried running that with a bigger channel bandwidth, that I kind of played around with the configurations a little bit. So let's take a look now at the LTE project, and I'll advance my slide deck just so I don't lose my place here. Going through sort of the same items in my LTE project now, you see I've got slightly different results. And if I drill down into the details here, I've got a higher ERP, 47 dBm ERP, and I'm at 2.2 gigahertz in this case. So this would be like if we had a private LTE solution and we had some spectrum in band 66 to work with. And maybe that's a consideration as a solution, because maybe that, there's some spectrum available that's up for purchase, but you're comparing it against deploying something in unlicensed or deploying a proprietary solution or Tirana or, something like that. So again, here I've set up the essential link budget parameters, including my channel bandwidth on the base station receiver and on my CPEs, and including my MIMO types. And here again on the propagation model, I've chosen that add clutter pass-through loss because I've got the same market area, and at a lower frequency band, we'll get even more screening through the trees and around buildings and things. So it's better to treat the clutter as a lossy screen here. Under the network design analysis, LTE Pro, I can go into system details and set up a default technology and point to a channel plan here. Although this dialog in a future release of the software will actually just go away. And since each technology, you can have more than one band in your project, and each one can have different configurations. You'll be able to, set up multiples under LTE or 5G. And And that can include things that are not broadband LTE. So that can include like NB-IoT and things like that can be in this list as well. The channel plan template is not critical for LTE planning anymore, because with the partial usage of subcarriers, the most common configuration is to use the entire block of spectrum and just use the PCI code planning to coordinate them. So in other words, on each of these, I essentially have the same channel, that same block of 2.2 gigahertz spectrum assigned, and the coordination of the subcarriers is being handled within the prediction based on the traffic level and so forth. And the last thing I should point out about this is when I set up my studies, I want to make sure to select the data rate study from the correct study group. So in the Wi-Fi version of the project, I went under the Wi-Fi system group and selected, what's it called here? Adaptive modulation downlink data rate. Now that I'm in that LTE Pro study group, it's called single channel downlink throughput, but it's going to give us the same output units, which is megabits per second deliverable to that CPE. Notice in here, a really important option is to include the MIMO and SDMA adjustments. If that's off, then you would get the pure level, assuming one antenna at each location. So it'll be based just on the coding scheme. Since you've got a MIMO array on there, you'll want to leave that checked on. And you'll also notice I've got some options here for whether to use noise and predicted interference or use noise only. In this case, I wanted to look at a pure coverage-based prediction, and so I set them all to use noise only. If I want to do traffic loading and load different traffic levels onto the CPEs, onto the users, then I can run these studies using noise and predicted interference to see how, with a given traffic load, self-interference might degrade some of the deliverable data rates. But of course, at the technology comparison level, maybe I want to look first at maximum data rates deliverable, and then look later at sort of what capacities would be supportable. So I just wanted to point that option out as one of the things I have set up here. Let's see, what else should I say about the LTE? Once I've set up all these essentials, my system type and the MIMO configuration and so forth. Once I have set this up, and maybe we've gone ahead and selected LTE as the solution for this particular use case, then I would want to complete this design by loading traffic on it, like I was just discussing. And so the way we can do that is in the network design analysis, we've got a traffic loading function here. And I'll go ahead and jump into that first. If I have a fixed FWA type project, then I'll probably want to put in each of those subscriber units as a fixed CPE. And so my multi-point, or my traffic source should be this multi-point traffic from CPE. And you can see here I can choose between the different multi-point groups if I have them, and I can choose which of the study types I want to use as the driver for this traffic planning. And when I calculate average traffic load on each sector, what it's going to do is look at the assignments of these CPEs. And let me go ahead and take a look at one of these CPEs here. Oh, whoops. Oh, I see. I need to update. Under my CPE here, it's set up to use the strongest server. So when I run the study, it's just going to go ahead and assign the CPE to whatever base station is giving it the strongest downlink power. If you wanted to explicitly assign CPEs to a particular server, either for capacity reasons or because that's what got deployed out in the field, you can always go in and set your multi-point studies. Oh, sorry about that. Set your multi-point studies to use assigned server instead. And of course, the study then will observe those assignments and the traffic planning will observe those assignments. But so when I click on this traffic loading, calculate average traffic load on sector, that will go through and predict how much load has been placed on each of my LTE node Bs, or this would work the same way for a Wi-Fi or a Tirana project. It's going to predict the amount of load in megabits per second on the uplink and the downlink. And then in the received parameters, if I want to look at how this would operate under load, I can check on this use load-based noise rise, and basically as the sector loading goes up, we'll assume a higher and higher noise floor so that potentially the data rate might be degraded on some sectors, especially heavily congested ones. In other technologies where we might not have the sharing of subcarriers happening in the same way, then we might have direct co-channel interference. And that's, if we're talking about like a WiMAX system, then we want to do actual channel planning to avoid that. In the case of LTE, we don't have to do that because instead we're going to do PCI code planning. So if I have set up my LTE network and they're all using the same block of spectrum, then I need to go in and do this PCI code planning, which will give me the PCI, PSS, and SSS numbers to assign to each of these sectors so that they can share subcarriers in a seamless way. Let's see, what else do I need to not leave out for LTE? Oh, and then there's, finally, there's the neighbor list function here under LTE Pro. If I go into neighbor lists, I can go in and I haven't run this yet, and we won't bother to wait for it. But what this will do is generate the neighbors for each of the sectors in here, and that would be part of the deliverables for a finished LTE network design. Let's go ahead and jump on to the Tirana example, and this could just as easily be a Motorola Canopy or a WiMAX or your name here proprietary OFDM solution. And that includes, equipment vendors. If in some cases, some of our users are equipment vendors that offer a solution. And one of the reasons they choose SignalPro and our WiMAX module is because it allows them to customize the coding scheme and customize the MIMO configuration to exactly what they're doing and be able to get the sort of data rates that they predict from their solution. And so one of the things about a Tirana solution that would make it really different would be the MIMO adaptive antenna configuration. Tirana uses a CPE or a subscriber device that has a big, massive MIMO antenna array on it, so it can leverage MIMO at both the base station end and the CPE end, which makes for a somewhat more expensive CPE, but also it means they have really high reliability and really potentially high data rates because they're leveraging multipath at the CPE end as well. And so if I wanted to account for that, and I go through the table here and see that none of the MIMO types that are already listed in here are going to give me the right sort of numbers as far as data rate. to agree with what Tirana predicts or what they show happening in the field. So if I go down to one of these user-defined lines, I can go in here and just set whatever options I want. And this is where I was hoping to have some numbers for this before this webinar, but I don't quite have them for the Tirana use case yet for their typical CPE. But because of the active interference cancellation that solution has, I would have some amount of interference reduction on both the uplink and the downlink. And I was drilling down into their spec sheets and their technical papers. I'm not totally sure what the correct number is to use for that interference reduction. I think it's actually more than I have here, but I would say check with the vendor if you're going to actually deploy that equipment. And then we also have a data multiplier here, which is going to take the base deliverable data rate of the coding scheme and multiply that to give us the sort of final achievable data rate. And here again, I wasn't quite sure what to put. The Tirana equipment and some of these other proprietary solutions are really leveraging the MIMO to get a high data rate multiplier in multipath environments. And again, that's sort of potentially something that may change depending on how much multipath is in the environment. And so you'll want to check in on sort of once you have some radios deployed and out there, it would make sense to check in and make sure that the data rate you're actually seeing in the field agrees with what you're predicting. And if it does not, it's worth asking the question, well, is this because of noise in the field? You know, is the noise floor higher than expected? Or is this because we're not getting as much MIMO improvement as expected? And yeah, there's a whole other topic we could go into about sort of diagnosing whether the solution is giving you the data rate that it should. But in the case of configuring a proprietary MIMO antenna where maybe the subscriber device and the base station have sort of exceptional performance because of a big MIMO array, you can do that under the user-defined line here. And also, of course, while I was doing that, I went into my adaptive modulation table and I set up a Tirana 20 megahertz speculative where I put in some data rates here, just, you know, based off really a table that I saw on the Tirana website of sort of deliverable data rates. Again, I'm not sure this is accurate for a 20 megahertz deployment of that solution, so I would check with the equipment vendor and make sure you get an updated table to put in here. But the nice thing, if you're trying to compare these different solutions and trying to look at maybe an existing cambium that you might have out there versus updating to something like Tirana or shifting over to something like LTE, by using these configurable AMOD tables for anything that's proprietary or IEEE, or in the case of the LTE and 5G, those coding tables are actually set up for you. Under the RAN import function, if I wanted to go into the coding scheme used for LTE, I can go in and look at that same, it's a very similar modulation table that gives the spectral efficiency and the signal to noise required to support that. And so whether we're looking at an LTE and 5G and the coding rates that it's going to support, or a IEEE Wi-Fi system, or something proprietary like Cambium or like Tirana, you can get that apples to apples comparison by just making sure that that adaptive modulation table and the MIMO options are set up correctly, and then ultimately running those data rate studies. And if you need to compare them under traffic load, then you can do that traffic loading based on the demand that you put on the CPE. So in my CPE types here, I can select the average demand that a user represents, and I could have different types of users if I want. And then I could load that traffic onto the sectors and see how each of these technologies is going to perform under that level of traffic load. And so that's sort of how I would go about comparing this. And again, I would take a look at the Study Queries tool and run these multi-point queries as sort of the ultimate output. If I want to see how many subscribers I've got at a given performance level for Wi-Fi versus LTE, ultimately I would drill down to these study queries to make that comparison. Let me make sure I'm not leaving anything out on where the final comparison. Oh, one thing that I did want to say about comparing these technologies, in this project, or this use case, I sort of assumed that we were going to use the same sites, as though I'm an existing network. Oh, can't take calls right now. I assumed that this was an existing network, that we were looking at modernizing all of the site locations. And so I went ahead and just used all the sites for each technology. Now, the reality is, especially if I'm comparing solutions in different frequency bands, I might have very different coverage. And so I would not use the exact same sites to cover this area with Wi-Fi at 5.8 gigahertz versus LTE at 2.2. I would need fewer sites in my LTE project. So if you're doing that, either the LTE module or the WiMAX wireless broadband or Wi-Fi, whichever one you're working with, you can use the automatic site placement either on an area-wide basis or here under multi-point. If you go to multi-point, create hub and transmitter group, you can have the automatic site selection choose the sites to cover a given area at a given frequency band, and you could either have it choose from the existing sites that are already out there in the project, or you could say, okay, here's a completely new set of tower locations. Show me the lowest cost way to get the coverage I need at this frequency band. And so that's another step that I might take, because if I go back and address like which of these sites do I actually need for LTE, I might find that I could drop out a lot of these sites that are down in the valley filling in holes, because at a lower frequency band we've got, better coverage. So the automatic site selection feature can definitely play into that technology selection. And then finally, if the area study queries by point feature, I just wanted to point that out because in most cases, we would put all of the fixed subscriber locations in as fixed CPEs like you have here. If you're looking at a full-scale metro area and you've got hundreds of thousands or millions of homes, then having millions of CPEs in your project might cause it to lag down and go slowly. And so one really efficient approach for that is to set up area studies instead. So, I could set up a grid study that shows, oh, gee, I've got pretty ubiquitous coverage from my LTE system. And then under the area study queries by point here, I can either have it look up the area study result for these locations based on the CPE locations, or I could just plug in a nice lightweight CSV file that gives me all of those millions of household locations and just simply looks up the area study result to go along with that location. And in the case where you might have hundreds of thousands or millions of CPEs, this is a much faster way to get the end result numbers for each of those locations. And ultimately, that's how you would make the comparison for, you know, which technology would serve those multi-point locations better. Okay, so we're coming up on the top of the hour here, and I wanted to open it up to questions at the very end. Rory, have any questions come in already?
No, we haven't had anything specific at this point, but there is a Q&A button if you want to type in a question. We can definitely take those in and answer them here for you.
Okay. I've advanced to the next slide here. Just a couple items. You know, I said at the beginning of the presentation that backhaul is really its own use case and its own topic. SignalPro gives you all the tools that you need to do that backhaul planning, though. So we really just talked about the access layer today, but if you're deploying an end-to-end network, especially somewhere that may not have a lot of fiber access, then chances are you may have to do some backhaul planning as well, or some backhaul planning will need to be involved. And because the base SignalPro package includes point-to-point link analysis and multi-point link studies, that backhaul planning is really easy to do. The important things are to make sure that you're using a more strict propagation model and clutter options for the backhaul layer to make sure that you're not getting non-line of sight backhaul links. But, you know, you want everything in the backhaul layer to pretty much be line of sight. And then multipath and seasonal fading. If we're looking to make a link that's, you know, 99.999% reliable, we want to account for seasonal and multipath fading. And so under the studies menu in reliability methods here, you have a place where you can set up the analysis method for multipath fading on the left. And you've got a couple different methods here. And then on the right-hand side, you've got rain fading analysis. And here again, we've got a couple different methods, including the ITUR and the crane methods. And then you can also do an alternate log normal fading. So if you wanted to look at the reliability of your backhaul during a big rain event, let's say during a big storm, you could actually put in a very large fading standard deviation and see which of your links might be affected by a big rain event. So that reliability and fading prediction is there under the studies reliability methods, and that's a really important part of backhaul planning. I would just say if that's something that you need to do and you're unfamiliar with it, do reach out to us through edx.com. You know, the support portal has a great knowledge base with some how-to articles. And of course, we're happy to answer questions and support you as well. So I'll go ahead and stop there. How are we doing, Rory? Are there any questions or did I make everything 100% clear?
Well, I think you made most things clear, Brian. It's at this stage, yeah, you know, if there are any follow-up questions, like Brian mentioned, you know, reach out to us. You know, something to note is we've had a lot of conversations recently with folks who are kind of navigating that migration away from Google Network Planner. And so, you know, one of those areas that we do focus in with our tool sets is exactly what we've covered here today. And so if that's something that you are also navigating, switching over from that and looking at, you know, tools that can handle those types of systems, we can definitely strike up a conversation and, you know, dive deeper into any of these subjects that you might be looking for. All right. Well, it looks like we haven't had anything else come in here on the questions. So, Brian, I mean, if unless there's anything else you have, we can wrap it up and say bye to everyone.
Okay. Well, great. Well, hey, everybody, thanks for your time and tuning in this morning. And like Rory said, if there's anything that we can help with, do feel free to reach out and we'll do the best we can for you.
Absolutely. Thanks again, everyone. Take care and have a good week.